Let's go ahead and I'm going to share my screen. Alright, so looking here, we have our side postulate, which says if you have three sides that are congruent to three other sides, then the triangles are then congruent. And the second postulate, side angle side, if you have two sides and the angle in between, okay, the included angle refers to the angle in between the two sides, okay? That is important. That never changes. That is not, that does not change, okay? One important thing to note is this angle of the triangle, angle A, okay? Let me just annotate this for you, right? Angle A, okay, is always going to be opposite side A. So this would be side B, and this would be side C. Okay? So what you would have to understand is you would have B is congruent to, we're going to call this side E. B is congruent to E. C is congruent to F. Okay? Excuse me. Angle A is congruent to angle D. Okay, so it's very important. Now watch how this helps you in terms of understanding whether or not the angle included is the correct angle or not. The two sides will have different names than the angle. That is a key. The two sides will have different names than the angle because the angle refers to the opposite side's name. Okay, if you don't understand that, we're going to talk about it some more. But it's important to understand that the two sides have different names than the angle that is included. Okay? All right, so there is side, angle, side. We talked about side, and side, angle, side briefly yesterday. Let's go ahead and talk about it in some more depth today. All right, here is our Jamboard. Okay, so if we call postulate 4.1, again, the number postulate is only important if you do not have an abbreviated name for it. Okay, so section 4.1, postulate 4.1 is side. Okay? If three sides, okay, postulate 4.2, one second. What? All right, so there's postulate 4.1 and 4.2. Now, when we do proofs, this is what I want you to write. If you're proving something, I want you to write it side, angle, side. Okay? Now, looking at example 1. Okay? Looking at example 1. Page 206. All right? Example 1 on page 206. They give you that AB is congruent to CB. All right? and you have this little triangular kite shape in the bridge. Okay, A, B, C, D. Okay, so AB is congruent to CB, right? And then they say AD is congruent to CD. Guys, this is very similar to what we already did, okay? Now, without actually doing a formal proof, okay, one step we're going to need is, if we're going to use side, 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 we need BD is congruent to BD, okay? And what would the reasoning for that be, Luigi?
Hey, Mr. Scrivener, I got here just now because of my Wi-Fi, so I might get this wrong. But I think that the reasoning behind why AB is congruent to CD is because they have the lines that denote that they are congruent sides. The lines going through the lines.
Yeah, so you'd say that that's given. Now the question was, why is BD congruent to BD?
Because they're the same.
Right, but what is the reasoning that we have to say when two things are the same? Rob?
They're congruent.
The postulate is SSS.
No. How come we can say that BD for the left triangle is congruent to BD for the right triangle?
Oh, because the 4-1 theorem.
No, it's not a theorem, it's one of the properties. Nazari?
Yes.
What property says that BD is congruent to BD?
Symmetry. Something about symmetry. Or reflexive.
Reflexive.
I was thinking like reflecting.
Yes.
Symmetric.
So listen, it's obvious that BD is congruent to BD because they're the same, okay? But because they're two different triangles, you have to say that basically side BD for the left triangle is the same as side BD for the right triangle. Because ultimately what you have is this. You have two separate triangles, okay? ABD, and you have BCD. Okay? And so basically what you have to say is that this one is congruent to this one, and the reason why is because they're the same. It is called the reflexive property. You have to say that in a proof. You cannot just assume they are the same because they are the same. Okay? You have to say the reflexive property says that they are the same because they are the same line. Okay? Now that we have three sides, okay, we're going to call this side 1, side 2, and now we have side 3, okay? So now we can say triangle. Now remember, it's important how you label this triangle, okay? Naomi, if you can't speak, could you put in the chat, what are the two triangles that are congruent? Triangle, give me the name of the first triangle, and then give me the name of the second triangle. Okay? So what are the two triangles that are congruent? Triangle what is congruent to triangle what? And remember, it does matter the order that you give me the letters. Naomi? Oh, there you go. Okay, so BAD and BCD. Excellent. BAD and BCD. Now, it doesn't matter what order you put the first one in, as long as you put the second one in the same order. For example, Naomi did B, A, D, B, C, D. Why is that important? Because A corresponds with C, B with B, and D with D. Okay? Very good. Okay? So, now what would the reasoning be behind this, Luigi? What is our reasoning behind BAD is congruent to BCD?
Because they have the same lines and, well, basically what I said the first time.
Okay, what do we call it? What do we call it when something has three sides that are congruent?
We call it symmetric.
No. So remember, in 4-1, you had to have all three sides congruent and all three angles congruent. Okay? But we've been given a tool in 4-2 that allows us to say that two triangles are congruent if they have three sides that are congruent to three other sides. Okay? Heidi, what is our reasoning as to why BAD is congruent to BCD? We have three lines that are congruent. What is the reasoning that we can now say the triangles are congruent? Heidi?
Oh, is it
Can you
that
say it one more time?
Australia?
Okay. Luigi, I said Heidi. Heidi, what is the reasoning as to why we can say triangle BAD is congruent to triangle BCD? Okay? Given that we just showed that we have three sides that are congruent. So what is the reasoning now that we can use, or the tool that we can use to now say that the two triangles are congruent because three sides are congruent?
The transitive property?
Not the transitive property. Guys, we're working on two postulates today. Only two postulates. So it's got to be one or the other. Okay? Nazari,
The side postulate.
SSS. What is SSS? Side, side, side. So when you prove that three sides are congruent, you can then say that the two triangles are congruent. Okay? Luigi, Heidi, George, I need you guys to join with your video. I believe Naomi's camera is broken, so she has spoken to me prior to this. Guys, listen, it's almost self-explanatory. When you have three sides that are congruent, you can then say the two triangles are congruent. And the reasoning is side, side, side. This is the tool that we have been given. Postulate 4-1. If three sides of a triangle are congruent to all three sides of another triangle, then the two triangles are congruent. Okay? The second postulate, if two sides and the angle in between are congruent for two triangles, then the triangles are congruent. So, you could take a wild guess, but the next example is going to be example 2, using side angle side. So when we get to this example, nobody better get it wrong as to the reasoning. Okay? So, example 2, what we have RS is congruent to TK. Okay? I'm going to just draw this picture really quick. RSKT. Okay? Now, they've given you that these two sides are congruent. Okay? Now, what other information do you need in order to prove that RSK is congruent to triangle TKS? Okay? What other information do you need to prove this? Okay? Again, we're going to use SAS, so we need side, angle, side. So again, watch. We have this side, so we either need this angle and this side, and this angle and the same side, or we have side and we need this angles and this side. Okay? Either way, we need two of those. Okay? We need an angle and we need a side. Okay? We have a side, so we need an angle and a side. Yes. What? It's okay. Just be more gentle. Okay, so we need an angle and a side. Alright? Now, we know what side do we know for sure? Oh, I didn't take out that angle. Okay, so we have the side. We have one side. We need an angle and then another side. Okay? Somebody give me a side that we automatically know is congruent based on the picture.
RS and TK. Or I mean KS.
KS and what?
SK.
Well, KS is congruent to KS. All right, Luigi, you get a redemption chance right here. What is the reasoning? How come we can say KS is congruent to KS?
Actually, I don't get it because I would answer that RS is congruent to KT because of the lines on the sides.
We already have RS in TK. They gave us that, right? That is given. Okay? But the second step is we need another line or an angle. We need an angle and we need a side. Okay? So another side is KS is congruent to KS. And the question I'm asking you, Luigi, is why? How do we know that? We just did this. The question is, how do we know that KS is congruent to KS? What property?
Oh wait, is this a reflexive property?
Yes, reflexive.
Oh, okay.
Anytime you have two triangles that share the same line in between you guys, this is going to be the reflexive property. Okay? Don't forget this. Anytime you have two triangles that share a side, you can say that that side is congruent to itself by the reflexive property. So now we have a side and then another side. So what we need is this angle and this angle. We need to say angle S, so we have a side. Now we need to say angle S is congruent to angle K. Okay? The question is, can we say that? Can we say angle S is congruent to angle K? Okay? So, what we need that information. If you could somehow prove this, then you could prove the two triangles are congruent. However, unless they told us that these two lines are parallel, which they haven't, okay, there's not enough information in order for us to prove that. Okay? So, if you did know that those two were congruent, you could then say they are congruent by SAS. So, like if they gave you angle S is congruent to angle K, you could then say the two triangles are congruent. All right? Let's look at example 2, the quick check. All right? So, in the quick check, they give you two sides are congruent. Two of the sides are congruent. Okay. All right. So quick check 2 on page 207. Okay. It looks like this. What? Okay. 8, 7, 7, 6. Okay, DABC. All right, so basically we can say DC or CD is congruent to AB Why? Because they're both equal to 7, right? Basically, you can say CD equals 7 and AB equals 7. So therefore, you can say CD is congruent to AB by the transitive property. Okay? So we have one. We can say AC is congruent to AC. Why, Luigi? How can we say AC is congruent to AC? Reflexive. Good. Reflexive. Okay? So we have two sides. Now, we need this angle and this angle. We need angle DCA congruent to angle BAC. Okay? We need this. If we get this, right, then triangle DAC would be congruent to BCA by SAS. Side, angle, side. Okay, here, pay close attention. Side, angle, side. Okay? Side, angle, side. Now, let's look at example 3. Are the triangles congruent? All right. Example 3. This is a good question because this is a little bit tricky. Are the triangles congruent? All right. Let's look at this. We have RED. And we have CAT. All right. Now, pay very close attention, okay? Can you prove that these triangles are congruent with the information given? Okay? We have RE congruent to CA. We have RD congruent to CT. Okay? Now, the question is, we have this angle R, congruent to angle T, okay? But the question is, we do not have enough information because this angle is not this angle. Meaning it is not included. You have side, angle, side, but here you have side, side, angle. All right? So therefore, no, you cannot prove that it's congruent. It might be congruent, but you cannot prove it. Okay? All right. Looking down at quick check number 3. All right? Now here we have a case where two triangles are congruent, but we're not going to be able to prove it by SAS. Okay? And here's why. You've got side, you've got another side, and we know that these angles are congruent because of vertical angles. Okay? So we have side, side, angle. Side, side, angle. So SSA, SSA. Now most likely these triangles will be congruent, but, oh actually I even drew it wrong, sorry. Oh, Zach. So you've got 1, 1, 2, 2. So we have this angle and this angle. Again, here you have side, angle, side. But here you have side, side, angle. Okay? So this they are not the same. Okay? You cannot say that they are the same. Even if they are equivalent triangles, you cannot say that they are because you do not have the same angles. Alright? You do not have matching angles. Alright. The corresponding angle, we have side, side angle. We would need this angle in order to prove that the triangles were congruent. Alright. Excuse me. We are going to do some practice, okay? From example 1, all right, we have all right, number 2. Actually, I want you guys to do number 3, okay? I want everybody to do, okay? Do number 3 on page 208, okay? And I want you to do number 9, page 208. I want you to do number 10, page 209. And number 14, page 209. Okay, go ahead and answer these 6 questions, okay? We're going to do this. I'm going to give you guys about 20 minutes to do this, okay? I'm not grading you on whether or not you get it correct. I'm grading you on whether or not you complete it. I'm grading your work, okay? So do your best, and then I will have you submit it to the Google Classroom after we go over the correct answer, okay? So do not submit it just yet. I'm going to have you correct your own work, and then I'll have you submit your corrected work.
Mr. Governor, I have one question.
Yep.
So, for instance, like in number 3, do we have to write down the given when we're writing down our answer?
When you're writing a proof, yes.
So we have to put down the given as well.
Right.
All right, good.
maybe some of the other half, please? Can you just not do the other half, please?
You need to keep working. Well, this is Zach. Yes. This is her husband. Yeah, we already purchased it. I'll be right back. 1 minute.
This is, we're done, can we send you a picture of this to Google Classroom?
What's up?
If we're done, do we upload images now?
No.
Okay.
In about 3 minutes, I'm gonna go over the answers, and then you can correct your work, like mark it off where you got it wrong, and write the correct answer, and then you'll submit your corrected page to the Google Classroom.
Okay.